All right, this is AP Calculus. This is Worksheet Solutions 5-3. I'll put key up here. Video solutions, here we go. The rule to remember for all of this is if I am taking antiderivative, it looks like that, and don't forget to use taxman, etc., etc. All right, let's do number one. So I need to rewrite this without a fraction. This is now going to be the integral of 16 times the quantity of 2x plus 1, no longer to the power of positive 5, but negative 5, because that's what happens when you move it between the numerator and denominator. You multiply by negative 1 for the power. This is still d of x. The u, the inside is 2x plus 1. The taxman, he's knocking on the front door. His name is 16. And if I take the derivative of this u, I get 2. All right, I'm going to pay taxman 16 divided by 2, which is 8. So rewriting down here, I now have an 8, and then I fill in all of this other stuff. 2x plus 1 to the negative 5. 2x plus 1 all to the negative 5 dx. Okay, I'm going to take the antiderivative. Here we go. The antiderivative, I'm going to go, I still have my 8. Ooh, what happened there? I still have an 8. I still have this base of 2x plus 1, but no longer to the negative 5. I'm going to add 1 and become negative 4. This looks very familiar, doesn't it? Divide down by negative 4. Don't forget your cake. Don't forget your plus c. And then we need to simplify and turn it back into a positive power just to practice doing that. And this is now going to be a negative 2 because 8 divided by negative 4 is negative 2. And this is all going to be divided by 2x plus 1 to the positive for, don't forget your cake, plus c. There is our final answer. How do we check this? There is always a way to check this. If I take the derivative, I have to go back and think of it as this type of function with a negative 2 out front. So I have, if the derivative is going to be equal to, I still have negative 2 times the quantity of, well, negative 4 is going to come down in front. So negative 2 times negative 4. All of this times 2x plus 1. 2x plus 1, all of this to the negative 5. And don't forget your dinner. This was doubter times dinner, which was 2. So negative 2 times negative 4 is 8. 8 times 2 is 16. And lo and behold, we started with a 16. That's the main thing that I'm checking. I know that this 2x plus 1 is going to be to the positive 5 if it's in the denominator. I'm going to go ahead and preemptively give myself the check. Yes, that does work. I'm trying to get the correct coefficient, and I did indeed get that. Let's move up here to number 2. Again, I'm going to rewrite this as the integral of 1. I'm going to kind of leave the 1 blank, of x minus 3 to the negative 5 dx. All right, what is my u? My u is x. Oop, what happened here? X minus 3. The taxman, there is no taxman, 1. The derivative of u is just 1. I'm not going to pay taxman anything because this is still 1. So when I rewrite, I'm not really rewriting, I'm really just saying the same thing. I can just copy and paste this guy down here. Oh, I don't need the integral, so I'll go ahead and delete that integral. All right, and then I'm going to take the antiderivative. I guess I can move him to the left to conserve space a little bit better. And to be consistent, I can make all of this yellow. All right, so now I'm going to take the antiderivative. This is going to be still x minus 3 for the base. This is going to go up a power from negative 5 to negative 4. Divide down by negative 4. And I'm going to add c. My constant of integration is its technical name. Our name for it is cake. Some people will choose Joe. We will come down here, and we can't really simplify it too much, just bringing this x minus 3 to the denominator and making this a positive 4 power. This is 1 over negative 4 times the quantity of x minus 3. That quantity to the power of 4 plus c. Final answer. Box it. Let's check our work. Taking the derivative. If I take the derivative of it, I'm kind of thinking of it in this form because I don't want to rewrite the fraction again. Take the derivative. This negative 4 is going to come down in front, and I'll get a negative 4 all over negative 4, and that's still going to be x minus 3 to the power of, it was negative 4, I go down, and I get negative 5. Do I have to worry about dinner? The derivative of x is 1, so my dinner is 1. Don't worry about it. Let's check. Those cancel out. I'm left with x minus 3 to the negative 5 and x minus 3 to the negative 5. So I check my work. It looks good. Check. All right, let's zoom back out. I'm on to the third and final problem from the front side. I need to rewrite this without a radical. So this is still the integral of 10. Now this is going to be quantity of 5x minus 7 to the power of 1/2 dx. All right, after I have rewritten this, I am now going to say that u is 5x minus 7. Taxman, he's right there. He's 10. He's knocking on the front door. And the derivative of that u is just 5. I'm going to pay Taxman 10 divided by 5, which is 2. So rewriting down here with a 2 out front, and I'm going to say 5x minus 7 to the power of 1/2. 5x minus 7 to the power of 1/2 dx. All right, so it is time to take the derivative, or the antiderivative. So the antiderivative, this is still a 2 out front. I have this 5x minus 7 all to the power of now 3 halves. 3 halves, and I divide down, so 2/3 right here. Don't forget your cake, plus c. Simplifying this, it becomes 4/3. So I come down here, it becomes 4/3, and I still have this 5x minus 7 to the power of, well, I guess I can make this into a square root, can't I? So power of 3 halves, that's really the square root of 5x minus 7. All of this to the power of 3. Don't forget our cake, plus c. Final answer, box it. All right, checking the work. I'm kind of thinking of this not as a radical, but kind of this form where I have to the power of 3 halves. So if I take the derivative, that 3 halves is going to come down in front. So if I have 3 halves out front, I still have that 4/3, and I still have this 5x minus 7. It was to the power of 3 halves. Going down, it turns it into a power of 1/2. And check it out. So these 3's will cancel out. 3's are gone. 4 divided by 2 is just 2, so cross cancel, leave a 2. So I should have a 2 square root of 5x minus 7, but I need to take the dinner. I've done the doubter. I need to multiply this now by dinner, which is 5, and 2 times 5 gives us 10. So we got the correct coefficient, so we can give ourselves the check, and we are on to the backside now. Wow, you guys are keeping up with me. That's impressive. I talk really fast. All right, so this one, we're going to rewrite. This is going to be the integral of 24x to the power of 2. Now this is going to be quantity 4x to the power of 3 plus 13. All of this to the power of 1/2. Don't forget our dx. All right, so what is our u? Our u is the inside. This is 4x to the power of 3 plus 13. Our taxman is this giant guy at the front, 24x squared. 24x squared. The derivative of 4x to the power of 3 plus 13 is 12x squared. All right, when we pay taxman, these x squares will cancel out. Luckily, I was sweating because we had that variable rate. And 24 divided by 12 is 2, so when I pay taxman, this guy is turning into a 2. This is now going to be 2, and then what's left over, I have this 4x cubed plus 13. 4x squared plus 13, all to the power of 1/2 still. Don't forget our dx. Let's go ahead and take our antiderivative now. Antiderivative, I still have that 2. I'll leave some space. I don't know if I have enough room over there. I'm going to have to go down here. This is now 2, leave some space. 4x squared plus 13, no longer to the power of 1/2, but 3 halves. I'm adding 1 to it. Divide by 3 halves is the same thing as multiplying by 2/3. And I just need to simplify this in terms of radical, in terms of the fraction. So my final answer is 4/3. And this is now going to be the square root of 4x squared plus 13. All of this 4x squared plus 13 to the power of 3. All right, and I'm back, and I noticed right when I started looking at this, I've been making a tiny little mistake here. This is a cubed, and a cube, so my bad there. Let's go ahead and change those all. So this should be to the power of 3, because the inner was power of 3. I don't know why I just randomly decided to change it to 2. That's a 3, and that is a red 3. All right, that would have showed up if we checked our work as well. So if we take the derivative, this 3 halves is going to come down in front with this 4/3. So I get 3 halves times 4/3 times this quantity of 4x to the power of 3, 4x to the power of 3 plus 13, and go down in power, or down 1, so it's 1/2. And don't forget your dinner. So this was all doubter. Dinner is 3 times 4. That's 12x. Go down to power to 2. All right, so let's cross cancel some things. 2 and 4 turns into a 2. The 3's are gone. 2 times 12x squared is 24x squared. And yes, cool, 24x squared, that matches up. We got the right answer. And I should really be boxing my answers, so there's that answer right there. All right, moving on to the next problem. We have a fraction. Let's go ahead and rewrite it to get rid of that fraction. I still have an integral of x on the top, and now this is being brought up, so this 3x squared plus 5 is being brought to the numerator, so it's now a negative, and it was a 1/2, so it's now a negative 1/2. And don't forget our d of x. Our u, the inner here, is 3x squared plus 5. Our taxman knocking out the front door is x. When I take the derivative, I get 6x. Luckily, our variables are indeed going to cancel out when we pay taxman. We're going to pay taxman 1/6. So coming down here, we're going to rewrite our integral. This x is being paid with 1/6, so I have 1/6, and this is going to be in parentheses this 3x squared plus 5, 3x squared plus 5. All of that is to the power of, well, it was negative 1/2. It's going to go up a power now to 1/2. I don't want to do that yet. I am taking the integral. I apologize. It's still negative 1/2 dx. Now I'm going to take the antiderivative. When I do that, I think I have enough room over here. I still have the 1/6. I'm going to leave some space. I don't have room. I lied to you. All right, come down here. This is equal to 1/6. Leave some space. This is 3x squared plus 5. Now to the power of 1/2, because I'm adding a power to negative 1/2. And divide down. Dividing by a half is the same thing as multiplying by 2. And don't forget r plus c. Let's go ahead and simplify this thing. So 2 times 1/6 is 1/3, so 1/3, and this is all going to be the square root of 3x squared plus 5. Don't forget our cake, don't forget our plus c. Let's go ahead and take the derivative to check our work, make sure we get all the same things. This 1/2 is going to come down in front. 1/2 times 1/3 is a 6, 1/6. And this is going to be 3x squared plus 5, and this is going to go down a power from 1/2 to negative 1/2. And don't forget your dinner. So dinner is 6x, and that means when I cancel out my 6's, I'm left with an x out front. Do I have an x out front on the top? I have an x on the top, and then this is a negative square root power. Woohoo! We got it. All right, so I guess I should say, yeah, we got it over there as well. Check, check, check. And our last and final problem, yep, there's no more pages after this. Go ahead and rewrite this one. This is going to be the integral of 3x squared is still the numerator. And that is going to be multiplied by x to the power of 3 plus 1, this quantity to the power of negative 1/2 dx. All right, so what is our u? Our u is x to the power of 3 plus 1. Taxman is this 3x squared. 3x squared, and the derivative of this u is 3x squared. Hey, those canceled out completely, totally gone. We're paying taxman with 1, so essentially that's the same thing as getting rid of that 3x squared. So when I come down here and rewrite this, it is only going to be, can't say words, x plus 3, x to the power of 3 plus 1. I will eventually pronounce things correctly, to the negative 1/2. dx. All right, let's go ahead and take the antiderivative. So this is going to go up a power. It's going to be x to the power of 3 plus 1. All this to the power of 1/2. And then divide by 1/2 is the same thing as multiplying by 2. Don't forget your plus c. And I can simplify this by making this into a radical symbol. So this is really equal to 2 square root of x to the power of 3 plus 1 plus c. Checking our work. If I take the derivative, again, this 1/2 is going to come down in front, so it's 1/2 times that original 2 times this quantity of x to the power of 3 plus 1. All of this to the power of, it was 1/2, and it's going to go down to negative 1/2. Don't forget your dinner. We just did doubter. Dinner is going to be the derivative of 3x to the power of, or the derivative of x to the power of 3 plus 1 is 3x squared. So times 3x squared. And notice when we cancel out the 2's, I'm left with 3x squared out front and 3x squared out front. This square root on the bottom is going to happen because I have a square root and a negative power, so that is also going to be on the bottom. Yes. All right. We have finished worksheet 5-3.